This video is for Chapter 15 of MTB 1370 when we are calculating drip rate from a manually regulated IV. And in order to calculate drip rate, we are going to use the formula volume in milliliters divided by time in minutes, and then multiply that by the drop factor, or some people call the calibration, which is in drops per milliliter. So a few key things about the formula. In order to use this formula, we have to make sure our volume is in milliliters. So if it's in liters, we would have to convert it to milliliters in the metric system. Time has to be in minutes, so if it's in hours, we must multiply by 60 to convert to minutes. And then the drop factor is always in drops per milliliter, the number of drops it takes to get 1 milliliter of fluid. And then what will happen is the milliliters unit will divide out, and our answer will be in drops per minute. So that's why our answer is in GTT per minute. Now, a short way to write that formula is just volume over time, so V divided by T times C, the calibration or drop factor, would be equal to the drip rate. Or you could multiply the volume times the calibration first and then divide by time in minutes to get the rate. Now these are video solutions to the Chapter 15 examples. There are 8 examples on the worksheet, and we will work our way through each of them. So the directions say calculate the drip rate for the following situations, round to the nearest unit. So when we calculate drip rate, it is very important that if you're a nurse and you have a watch count and you're counting the drops in the drip chamber, you only can count full drops. So we have to round our answer to the nearest whole number or the nearest unit. So do not leave fractions or decimals in these answers. So in the first problem, you are asked to administer 100 milliliters of saline over 30 minutes using a 15-drop set. Remember, a 15-drop set means it takes 15 drops to get 1 milliliter of fluid. Well, in this problem, we want 100 milliliters. So again, the formula that you could use would be volume, which must be in milliliters, divided by time in minutes, times the calibration or the drop factor, and that's what's equal to the rate in drops per minute. Make sure we write our answers correctly as well with the correct units. So in this problem, the volume is 100 milliliters. So we have 100 milliliters, no conversion needed there because it's already in milliliters, divided by time, T, in minutes, which it's already in minutes, it's 30 minutes. And we times that by the calibration or the drop factor, and the drop factor is 15. Now remember what that means. That means there's 15 drops per every 1 milliliter. So if we multiply this out, the units of milliliters will divide out, and our answer will be in GTT per minute. GTT in the numerator, minute in the denominator. And at this point, you can either multiply and then divide, or you could divide and then multiply. One thing you don't want to do is do any rounding until the very, very end. You don't want to go 100 divided by 30 and get a decimal and round that decimal and then multiply the rounded decimal by 15. You do not want to do that. So if I multiply 100 times 15, I get 1500. And then divide that by 30, and you'll get 50 drops per minute. So if you do the math here, you would get 1500 drops are needed. That's 100 times 15. And then divide by 30 minutes. You want that evenly spread out over 30 minutes. So that means you want 50 drops, GTT, every 1 minute. So about a drop every second coming into the drip chamber. So that is our answer. Make sure you have the right quantity and the correct units, drops per minute. Think about a nurse counting the drops in the drop chamber. So in the second problem, we have a little bit more fluid. We have 1,000 milliliters, but now it's over 24 hours. And it's using a drop factor again of 15, which means it takes 15 drops for every 1 milliliter. So the volume is here. The time is 24 hours, but it's in hours, so we have to convert that to minutes. And remember, the way you convert that to minutes is times that by 60. So if you went 24 times 60, you would get 1,440 total minutes. So now if we go back to the formula, we have the volume, which is 1,000 mLs. Now we know the number of minutes, which is 1,440 minutes, because we had to convert our hours into minutes. And then times that by, well, it takes 15 drops for every 1 ml, because that's the calibration or the drop factor. And if you multiply that out and divide, so you can either divide first and then multiply, or go 1,000 times 15 and then divide by 1,440, but again, don't do any rounding till the end, you should get roughly 10.4. But recall, we don't write it as a decimal or a fraction because we're counting drops. So if it's 10.4, we round to the nearest whole drop, which would be 10. So it'd be 10 drops per minute. That means like 1 drop every 6 seconds. Because in a whole minute you need 10 drops. So every 6 seconds we should have a drop coming into the drip chamber. So in the next problem, looks like just simple arithmetic here, no conversion. So it's 350 milliliters divided by the number of minutes, which is 180 minutes, times that by the calibration, which means it's macro drip because they're bigger drops because it's 12. So it's 12 drops per every 1 milliliter. The milliliters will divide out. If you divide and then multiply, you'll get 23.3 repeating, and to the nearest drop, it would be 23 drops every minute. That means a drop roughly every 3 seconds. Every 3 seconds, you'll have a drop. It says here the order is for 500 milliliters of saline at 250 milliliters per hour using a drop factor of 15 again. So, since it says 250 milliliters per hour, that is our relationship between volume and time, except it's hour there instead of minutes. So we're going to have 250 milliliters per hour, which means per 60 minutes. And we're going to times that by a calibration or a drop factor of 15 drops for every 1 milliliter. The milliliters will divide out. Our units in our answer will be drops per minute. And if you divide and then multiply, or multiply and then divide, you will get 63 once you round it. You get 62.5, and that rounds to 63 drops per minute. There is also another way to do this problem using the total volume. But if you use the total volume, there's a little bit more thought involved, because if it's 250 milliliters per hour and you want 500 milliliters, well, that's going to take 2 hours because 250 goes into 500 twice. So an alternate way would be to take the total volume of 500 milliliters and divide it by 120 minutes. That's because that's 2 hours. And times by the calibration, which would still be 15 drops per 1 milliliter. Then the milliliters divide out, and when you divide and multiply, you're still going to get 63 drops per minute. That's a little bit more challenging because in order to if you want to use the total volume, you have to find the total time, which means you had to figure out if the rate was 250 milliliters per 1 hour. Well, if you had 500 milliliters, how many hours would it take? And since 250 times 2 is 500, that tells you it would take 2 hours, which is 120 minutes. Now the next 4 problems are going to be very similar. So this is very similar to the previous problem. They give us a relationship, and let me write that formula up here. Recall it was volume in milliliters divided by time in minutes times the calibration is equal to the rate. And we said you could multiply V times C and then divide by T if you wish. Or you could divide V by T, take that number and times it by C, but don't do any rounding in intermediate steps, only round at the end. So again, the easiest thing to do would be to take this relationship of volume and time and go 200 milliliters divided by 60 minutes and times that by a 20 drop set means there's 20 drops that it takes to get 1 milliliter. So the drops are a little bit smaller because it takes 20 drops to get 1 milliliter. It still is macro, it's not a micro drip set yet. That's only when we have a 60 calibration drop factor. Now when we multiply this, the milliliters will divide out. Our answer will be in drops per minute because those are the units that remain. And then if you multiply and then divide, or divide and then multiply, you'll get 66.6 repeating. And since it's 66.6, we round the 66 to a 67 drops per minute. Number 6, we have a volume, we have a time, but it's in hours, and we have a macro drop set again. So it's 200 milliliters, 1.5 hours, so you would have to go 1.5 or 1.5 times 60 minutes. And that would be, well, 1 times 60 is 60. A half times 60 is a 30. So that means you add those, you get 90 minutes. You probably knew that 1.5 hours was 90 minutes. And then times that by the calibration, which is 10 drops per 1 ml. And the mLs divide out. And if you do the arithmetic, 200 divided by 90, do not round. Take that and times it by 10, because 10 is like 10 over 1. You'll get 22.2 repeating. And since it's 22.2 repeating, we keep it as 22 drops per minute. Using a 12 drop set, the order is for 900 milliliters, so it's in milliliters already. Remember, if it was in liters, we would have to convert it to milliliters by multiplying by 1,000. Converting from liters to milliliters, we'd have to multiply by 1,000, but this was already given in milliliters. The time is in minutes, 160 minutes. We times that by the calibration, which is 12 drops for every 1 milliliter. The milliliters divide out. If you go 900 divided by 160, push equals, get an answer, times that by 12 without rounding, you would get 67.5, which we know we can't count half a drop. We can't have half a drop, so it's going to be 68. We round up because the 5. If it's 5 or higher, we round up. So that's 68 drops per minute. Then the last problem, we do have a micro drip set. So a micro drip set, that means they're very small drops, and it takes 60 drops to just get 1 milliliter. It takes 60 little drops. So again, same formula. We take the volume, 300 milliliters. We divide it by time in minutes, which is already in minutes, 240 minutes. And then we times that by the calibration, and since it says micro drip set, that tells us that it's going to take 60 drops to get 1 milliliter of fluid. So those drops are very, very small because it takes 60 of them just to get 1 ml. The mLs divide out. Our units in our answer will be in drops per minute. And if you divide and then multiply, you get 75 drops per minute. So again, this was from Chapter 15, dealing with drip rate in MTB 1370.